Hi, in this chapter, we will understand what are the types of data and their ways of storing them, that is, the data structure. Data types, in simple meaning, defines what sort of value it is. The most commonly used data types are numbers, which is called as numeric values in R, and text, which is again a character value. Then, the data structure in R programming language refers to the structure of storing the data in R. Some of the few common data structures are vectors, matrices, list, and data frame. Let's learn each of them in detail. Number 1. Vectors. Vectors are the collection of values that has the same data type. A vector can be numeric or a character. It can be used to represent a single variable in a data set. Number 2 is the factors. Factors are also a collection of variables that are used to categorize the data and store it as levels. It is similar to a vector except they can store both strings and integers. For example, number of gear types in the column of the empty car dataset. When we will use the R to identify how many types of gears for those cars available, it will display the results as factor W/3 levels 3, 4, 5. That is factor with 3 levels of 3, 4, 5 types of gear. Matrices. Matrices is a two-dimensional collection of values where again all having the same data type. Now the values in matrices are arranged in rows and columns. Here I have set an example to create a matrix in R by typing matrix vector of values in the form of C123 3 to 1, number of rows is equal to 3, number of columns is equal to 2, and save it as R object. To access those values, simply use the R object A, then define the positions in row and column format. For example, A first value of the row, comma, blank, then close the bracket. Blank space refers all the values of the column. The output will be 13. The same goes with the second one. And for the particular value, just define the row and the column position of that value. The third most popular data structure is the data frame, where values of same or different data types are stored in a single table of rows and columns. To create a data frame from the scratch, use the factors or directly convert a data file into a data frame. And lastly, the list, which is a collection of objects of same or different data types. In the example below, we can see the data values are stored as list and not as a data frame, matrix, or vector. Again, to access these values in the list, we have to use the list position. We will perform all this again in our lab videos for hands-on experience. Now, let me take you a walkthrough with some R examples. Data frame, as we know, it is a table of rows and columns, and to create a table, simply define the vectors inside the data frame function. The vector name will represent the column name and the values of the factor. To know the type of data structure of the R object, like the one we just created, marksCard, simply type class marksCard, and to access the elements of the marksCard, type marksCard bracket blank then comma 3, that is in the format row comma column. We will have now third column as the output. The same goes with the next one except this indicates for rows. R comes with pre-installed datasets for practice and debugging purpose. So we will load the iris dataset for our practice purpose. To view the column names of the dataset, type the dataset inside the names or column names function. To view the data structure of the dataset, simply type structure str in short, and the same goes if we want to know the dimensions of the dataset. To view the numbers of rows in the dataset, use nRow function, and for columns, use nColumn. And to view the whole dataset, simply type view with the dataset name saved in our R object. Head and tail for the top and the bottommost values from the dataset. Define the values to view the few top or the bottommost data of the dataset. R also provides the full documentation of each packages and functions to make it flexible and scalable to handle different types of data. And to view the documentation of each packages, we simply have to add a question mark with the function or the package name. As we are aware of calling the values of the dataset by their positions in row and a columnar format, we can also call the number of rows and columns using the same row and columnar format. For example, this iris dataset define the range of positions like 15 to 20, then comma, blank space will refer all the columns. Close the bracket and done. The same goes for the second example. Even we can easily access all the values of a particular column by using a dollar symbol. For example, dataset dollar column name, and to access a particular value from the column, define the position and it's done. For a range of values from a particular column, again simply define the range. R also provides a simple, easy feature to understand the distribution of data like mean, median, mode, quantile by simply using the summary function. We can also confirm the data type of a variable by using is.character, dataset name, dollar, column name to check if it is a character data type, and is.numeric for numeric data type. The output of this will be logical in nature, that is true or false. We can use the attach function to take all the columns of iris dataset and create an individual objects so that we don't have to use the dollar symbol to call the columns of the dataset. Here we have used the column name straight away to call the column values. And remember, it's better to detach the dataset after we are done with the dataset, because R uses the system's RAM to perform its task. To view the current working directory of R, type get wd, that is get working directory. And of course we can change it by defining our desired location in the set wd function, that is set working directory. Similar to detach, we can also use garbage collection, GC in short, to automatically release the memory when an R object is no longer used. It does this by tracking how many names point to each object, and when there are no names pointing to an object, it deletes the object. By default, this function is already enabled. Next, we will learn how to import and export data in R.